Hello there, I'm Zert, and this video will be a developer's commentary and explanation of how I made the game 8 Squared. So if you're not familiar, 8 Squared is a game I made in Game Builder Garage. Let me boot it up for a second. So it's a simple platformer game. Each level is composed of 8 by 8 tiles. Each tile can be a different, either black or white. And you just play as this person Nodon who goes from the start, and your goal is to reach the end. What's special about this game, as you can see there, is that within the same game ID, there's multiple levels. There's 64 levels in fact, which is 8 squared. And all the levels, you can notice, are being generated in real time. And if you think about it, since there's 64 different tiles in each level, that would mean I was able to place like up to like 64 times 64 different blocks in the entire game. If you're familiar with Game Builder Garage, we only have a total of 512 Nodons. So usually in platformer games, each single block requires one Nodon. So making a game with 64 different levels, with each level having 64 different tiles that are possibly manually placed, would feel kind of impossible. So the goal of this video is to teach you the steps on how I thought about this and how this is possible, how this was made possible in Game Builder Garage. So let's get to it. So before I go into 8 squared itself, I think I need to go through the history of 8 squared in the first place, because I think it would be much easier to understand how it works when we go to the much more simple examples. 8 squared is actually the combination of several different games I've made in the past. So all of it started with this game, which is 8 squared over 2. So originally it was made for the third Dojam, or the game jam organized by Video Dojo. And for this specific game jam, the theme was to make a game using only 64 Nodons. See here, this game only has 64 Nodons, so it was submitted for the Dojam. So my goal here was, I was trying to make, if you're familiar with GBG, 512, a lot of people already think that's way too little. Like, how are you supposed to make a game with 512? Or it's going to be very limited with 512. And when we put it down all the way up to 64, it's going to feel impossible. For this specific game, I was trying to think of how would I make a very long game using only so little node count. The best answer I could think of is I definitely should be using the launcher Nodon. So the launcher Nodon is basically a Nodon which, if you activate it, it can spawn a block. And there's specific launcher Nodon which can launch up to 100 different blocks. So using just one Nodon, if you're somehow able to control where you launch the blocks, you can save up to 100 Nodons using just this one Nodon. But you need to have some sort of system to control it, control where it moves and where it's going to activate to make a specific level. So for 8 squared over 2, with only 64 Nodons, I was able to make a game that actually has 32 different levels. So I have a video of it on, or a playthrough of it on my channel, but yeah, here's just a little teaser of what it looks like. There's 32 different levels of this. This was all done in just 64 Nodons. So you notice like the way the level generates is quite similar to 8 squared. It's pretty much almost the same, there's just a few little differences. So let's try to explain first how I achieved this kind of game. So let's start with trying to make it from scratch. That would be a good way to go through the learning process or the thought process on how you would make a game like this. Let me make a copy here and just delete everything else. I can delete that. I don't think I keep that. Just to make things simpler later. And I think I have to keep moving it back. There we go. So we have this blank slate of a game. Now the first problem is, how do we position? So we already know that we're going to be using this launch Nodon. So normally, let me align it to the grid first. Solid box. Normally, if you have this, it's just going to spawn a box in that position. So what we want to do is to somehow control where this thing moves and activate it at very specific times to create a level. The first step is, how do we make it move across the whole level? So since each level is made out of eight rows and 8 columns of tiles, we would theoretically need to be moving this launch Nodon from like this position. It's gonna move one tile, one by move to each tile one by one, in like sort of a zigzag pattern to be able to go through all of them. So well, there's many ways you can do it. You could be using a person Nodon. You could use a UFO Nodon to move attached to the launch Nodon. Like this is a very simple example. I attach it to a UFO here. Attach it to here. You can see I can move where the launch Nodon is using the UFO as a carrier for it. But that's the UFO is a bit quite too small. There's also like other options like the moving object, rotating object, or the free slide connector. Yeah, free slide connector. So free slide connector is also a very good choice because like you can control exactly where you want it to go. For instance, we put it there, and when we add in offset to the input, we can move it to the next tile over. So that's also a good option. But for my case, I feel like the free slider would cost a little bit more, and the best solution I could find was actually to use teleporters. So let's just use this dice here as our thing that moves the launch object. So right now the dice is just there, so it's just gonna spawn there. Actually, let's put a button here just so we can activate it whenever we want. Here, like there, you activate the launch Nodon, it spawns there. So how do we make this dice move across the whole level? So with the teleport Nodon, like we can directly like put the teleporter on the next tile, and then teleport the dice. So let's say activate the dice, connect the same button. So when I activate A, it spawns there and moves to the next tile. Problem here is, well, we're gonna need to teleport to the next tile over and over and so on. So one elegant solution we can do here is we can just attach this exit to the dice so that whenever the dice moves, the exit moves along with it. So let's see. Well, if we just connect it to the edge here, teleport is going to be moving there, so it's not going to be quite aligned, but you can see that we're able to move that teleporter each time it moves. So right now it's like, since it's connected x plus to x minus, it's going to be connected here. So if we wanted to move exactly one tile, we just make the teleporter larger so that when it connects from the x minus here to the x plus, connects right here and exactly where we the next tile over. So now whenever I press the A button, now it moves correctly to the right spot. The next part is we need to move it upwards. So you can use the same thing. You can use a teleporter B. And now we size it up to go up. Then let's use a similar teleport here. B. Activate it using a different button. And now when we and also we need to connect it on top of it. So now it's gonna be like connected like here. Yeah. So when we press A, go there, then B, then A. So now we need to. Well, right now there's our teleporter is on the right of the dice, so now it doesn't go back. So one solution that we can do is just attach another teleporter here, attach to the left of it. So it's gonna move on the left on odd rows and the right on even rows. That's one possible solution. But the more efficient solution, a more elegant solution, is to make use of the rotations of the, or make use of this reset setting of the teleporter. So what the reset setting of the teleporter does is that if it's set to reset, regardless of which way the object that's teleported is facing, after it's teleported, it's going to be facing the same direction as the teleporter exit. So for example, if we disconnect this teleporter exit, then say rotate it the y-axis by 45, when we activate the B, as you can see the exit is rotated in such a way, the dice will be rotated in a different way. You see here that since the first exit is connected to the dice, the first exit is also rotated. So what if we can rotate it in such a way that is going to place the first teleporter on the other side? So now we have, using the same teleporter, we can also move to the left side. So to do that, we just rotate it by 180 degrees. So when we press B, now it looks a different way. Actually, we can just connect it back here and it will do exactly that. Now keep in mind that when you connect objects to each other, we can only rotate the objects connected to it in... First of all, it needs to be connected... It needs to be not connected to the center. So it only works if it's connected to... If the connection setting is any of these settings, neither of them must be center. And also it only works in increments of 90 degrees. So for example, if I put back 45 degrees here, or let's say 44, you press B, it doesn't work. So it only increases by 90-degree increments. So like 49, for example, will round up to 90 degrees. So now, right now it's rotating 90 degrees each time. And 180 is just a multiple of 90. You can see, yeah, right now each time it goes up, it rotates. So when we activate it now, you see that it works exactly how we want. So in my original game, I added something a little extra to make it generate a bit faster, but here let's just keep it simple. Let's just put a timer to activate it each time we want it to work, or each time we want it to teleport and launch an object. So let's just put a timer here. Say we want it to move every 0.5 seconds. You can activate the A teleporter with that. Constant with that. And we want to move up every eight activations. So that would be 0.5 times 8 is 4 seconds. So when we connect all of these, did they connect correctly? Okay, not that one. So now let's check. Every 0.5 seconds, we're gonna move to activate teleporter A. Oops. Oh, so there. Right now, what's happening is whenever this activates, you can see that it activates at the same time as teleporter A. So teleporters can only teleport one thing at a time. You can't teleport it two things at once. And also we want it to move up. We don't want it to move to the right. So whenever this activates, we don't want this to activate as well. So we can fix this with like adding like a different logic like ands and nots or comparisons. But the more elegant solution is we can just change the teleporter exit letters. So if we switch A and B here, you'll notice that now, for some reason, it's gonna work. And the reason for that is actually the letters that you put here actually matter. So what the letters here indicate is the priority of which teleporter will be activated when multiple are activated at the same time. So if that just means like, for example, if we're activating two teleporters at the same time, for example, A and B, looks through here, which one is first, A or B, you'll activate A. So if we chose, for example, teleporters, if we activate teleporters D and F at the same time, it will prioritize D first if both of them are activated at the same time. Or E and F, it will choose E, A and H, it will choose A, and so on. So by using that little mechanic, whenever we activate teleporter A, or whenever we activate this upwards teleporter, it now ignores whatever signal is sent to the lateral teleporter. And now it works exactly how we want it to. See here? It's gonna move a zigzag way all the way up to the end. And original game, I just put a destroy object here so that whenever this reaches the end, it's gonna break. So let's just make it a bit faster. What happens if I put... Let's just show that it works all the way to the end. Is it correct? Yeah. Now, it does a zigzag and reaches the end. And here, there's just black spaces here because the launch object has a sort of delay when it can launch again. So right now it's just moving too fast to activate correctly. Actually, if you want to go at max speed, set 2.1 and this 2.8. There we go. This is it moving at max speed, assuming that it's spawning a tile each time. There we have it. So now the next step is, how do we actually tell the launch object when to activate, when it should activate, or how do we hard code it, when it should be activating or not, when it goes through this whole system. So let's look back at the a²/2, for example. So here, the launch object activates each time, or activates whenever its input is not 0. So like for easier understanding, let's just say 1. So it activates when it's 1. And if it's 0, it doesn't activate. So that means when we look at the input of the launch nodon, when it's moving across this whole level, it's going to be 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and so on. You're just reciting those zeros and ones. For those of you who are more familiar with like programming and stuff, it'll usually come to mind that a possible solution to this is to use binary numbers. So what if, or our goal here now is just to make a string of ones and zeros, and somehow use that, or like for example, we're gonna hard code a number that's like 10100101, and somehow go through each digit one by one each time the launch object moves to a different position, and check the value of that digit and then activate the launcher when it's on. So yeah, let's try to think about how we can do that. So how do we store in GBG a number, or yeah, how do we store a number of different ones and zeros? So if you're more familiar with programming, the simplest solution is to convert a number to binary. So here I just have a setup here. So binary is basically if you want to represent a number in ones and zeros. For example, 1 here, or yeah, example we have 1 in binary, that's 1. When we go to 2, it becomes 1 0, 3, and so on. So if I just increase the number, this is what the number is gonna look in binary. So like when converting to binary, we're not actually changing the number itself. Like this is still 476 in value. We're just changing how we write it. It's like a different language of number. So, but even if like they look different, we say this is the original 476. In the language of binary, or also called base 2, this is what it's gonna look like. So looking back in our game, if we want to store, for example, a specific string of numbers, like for example, if you want to spawn a on our level a combination of tiles that go like white tile, empty, white tile, empty, empty, white tile, empty, white tile, we could just store or put in our game the number 357 and then convert it to binary and then read its digits one by one. So like we can send, or we can convert, we save this number, convert it to binary, and then we send to the launch nodon each of its digits one by one. So for example, when it's on the bottom left, it's gonna be, we're gonna send it the first digit, then when it moves, go to the next digit, next digit, next digit, next digit, next digit, until it reaches the end. And how this is helpful to us in saving nodons is that instead of saving like different positions, like instead of having to put one object nodon in each position, we can just save the information of where each block is stored in just one number. Like for example, here, like let's just make a big number. Like here, we're able to store, like we're just using the number 659. So 659, we can just use a constant nodon for that. Just one constant nodon. And we're able to save, how many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different, or the state or the information of whether or not we have a block in 10 different positions in our level. So by just using one nodon, we're able to store 10 different tiles in our level. So that's the main concept of how we're gonna be saving nodons and how we're gonna be making entire levels, 64 by 60 or 8 by 8 entire levels using just a few amounts of nodons. So we're saving information, or we're storing information in a very cheap number, just one number. We're just gonna have to build like a sort of computer that translates this number into these digits that we want. Yeah. So how do we do that? So first off, we need to make a way that converts this number to base 2. So a little bit of background first. So how changing base words. So actually, the numbers that we're all familiar with, like yeah, these numbers I'm walking through, we're actually in base 10 right now. So all the numbers that you're familiar with, everything that we do, except if you go to like computer stuff, is in base 10. So what that just means is as there's 10 different symbols for each digit. So like we know you have 1 through 9, which is 9, and then 0. So that's 10. So that's why it's called base 10. And whenever we like go over the 10th digit, we add 1 to the next place. That's how base 10 works. But when we go to different bases, for example, say here you have like 6. If we go to base 9, here we're setting to base 9. Base 9 means it only has 9 digits. So that means, but that basically means we're getting rid of the 9. So after we go to 8, we go to the next one. Since we got rid of the ninth digit or the digit or the 9 symbol, immediately goes to the next place and then keeps on counting. So base 9 and base 10 are quite similar, or like quite close to each other. So like for example, in 20, base 9, 24 would be represented as 26, and it like goes slightly different the more you go. And when you go to different bases, it's the same concept. So like base 7, that means there's 7 symbols, and it goes up to 6. So 1, 2, 3, 4, 5, 6, and you go one more. The one, or this will go back to 0, and it'll move on to the next digit much earlier than base 10. And it's the same thing for every single digit. So for example, once we go to 66, so after 6, it goes back to 0. So after 6 goes adds 1 here, but this is also 6. So it just carries on as well. So it's the same thing in like base 10 when you have 99. You add 1, and 99 becomes 100. So it goes, 1 goes here, then it goes the next one. That's 100. That's basically how bases work. So when we move back down to like, for example, that's the number here, like we have 12, we have 13, and we go down to base 2 or base 2, which is binary. This is what it would look like. So every time, yeah, so at base 2 we only have 0 and 1. So that's why it's base 2. There's only 2 symbols. So 1, this is 2, 3, 4, 5, 6, 7, 8, and so on. So that's how this is a short primer on how bases work. So how do we get, the question now is, how do we get, or how do we isolate each specific digit? A good way to understand this is if we started with base 10, since we're all familiar with base 10. For example, in base 10, what do we do if we want to get the last digit? The easiest way is to just divide it by 10 and get the remainder, right? So like for example, 136, if divided by 10, you get 13, remainder 6. So if we had some way to get the remainder 6, it would give us the last digit. And that's because it's in base 10. If we move on to like base 8, we can do the same thing. If we divide, for example, 52 by 8, you will see that the remainder is going to be actually 4. Here's a simple example. Like, for example, 11, you divide 11 by 8, you get 1 remainder 3. There. 1 remainder 3. So that's how, even in different bases, how you get the last digit. So the operation that we use to get the remainder is called the modulo. So like, let's go back to base 10. For example, here, 12 modulo 10. 12 modulo 10 equals 2. So modulo just means what is the remainder when we divide it by this number. So going to like base 8, 12 modulo 8 gives us 4. That's the remainder. And so on. So if going back to base 2, if we want to get the last digit, for example, we just get 19 modulo 2, that will give us 1. And 20 modulo 2 give us 0. And it's going to go back and forth as we go through these numbers. So how do we get a modulo? I won't go too much into it, but in Game Builder Garage, the most effective way to get the modulo is by using 2 maps and a angle difference nodon. So I won't go much into how this works. But the crux of it is the angle difference nodon actually does modulo. It's just not it actually does modulo, and we're just making use of maps to change what modulo it's doing. So to do that, we set the first map. Let's set the output range to -180 to 180, and then the input of the second map to -180 to 180. We set the output of the first map is this range. The output of the input of the second map is this range. And then the modulo that we do is just whatever number we put here. So for example, it says here. So if we want to do modulo 10, so the first the left input of the first range is 0, and the output, this should be 0 as well. So if we want to do a modulo of a certain number, for example, let's get an example here. Let's say 59 or 681. 681, if you want, let's get a better example. 685. If you want to get the modulo 10 of 685, we set this second number to 10 and set this to 10. And you're going to see here, the output is 5. So let's give more examples here. So if you move this, change this to like 683, gives 3, 2, 1, 0, 9. So this basically just the modulo for us. Now, okay, we found a way to get the last digit. How about the other digits? For example, this second digit, 7. How will we get that? So if we're working on base 10, the intuitive thing would be to get rid or cover this last digit. So we get 67, and then we do the modulo 10 on that. So you divide. So how do we do that? So what we can do is divide this by 10. So you just use this map to divide by 10. So this is just a map that divides by 10. So when we put it here, 679, it's 67.90. And if we get the modulo 10 of that, we're going to get 7.9. So we're close to it, but since there's a 9 on the end, it's a little bit more. So an extra thing we can do is to round down. So how we round down in Game Builder Garage is by just putting a digitize, set to 2, and subtract it by -0.5 here. So yeah, it just rounds down. So 7.4 rounds down to, or 7.9 rounds down to 7. So now, after dividing it by 10, then doing modulo 10, we get the second digit. So let's just try it out to see that it actually works. So 412, this is the second digit. Actually, let's keep the original setup for the first digit here so we can see them both at the same time. There. So this gets the first digit, 2. The next digit, we divide by 10 and do the same thing, get 1. Then if we want the third digit, so this divides by 10 and gets the second digit. If you want to get this third digit, we do the same thing. We just get rid of these two numbers and just modulate by 10. So if you want to get rid of, if you want to move these two numbers to the right, you just divide it by 100. So we already have this division by 10 here. So if you divide it by 10 again, 412 divided by 10, you get 41.2 and 4.12. Then if you get the modulo 10, or yeah, if you get the modulo of 10 of 4.12 by 10, we're gonna get 4.12, and we round that down, we get 4. So now we're able to split up the different digits of a specific number. 412 goes to 4, 1, and 2. So how do we... Okay, so this is how it's done in base 10. Now, when we go to base 2, we just change 10 into 2. Or what if we, let's try, for example, base 9. So if we want to do base 9, you want to do modulo 9 here. So just get a simpler example, like 13. So 13 modulo 9. So what's the remainder of 13 divided by 9? That's 4. 13 modulo 9. Let's confirm it. It's 4. So for this modulo setup, you just change this number and this number to whatever number you want to modulo in the input by. Then for getting the different digits, we can, instead of dividing by 10, we just divide by 9 instead. And same here, and same here. So let's get a more complicated example, like 359. So this says 359 in base 9 is 498. Let's confirm that. 359. 359 base 9. 59 base 9. 438. There we go. Oh wait. Oh, I forgot to set it there. This should be 438. There we go. There we go. Yeah, 438. Just check it again to make sure that it actually works. 1, 2, 3 is 146. And let's confirm it. 1, 2, 3. Base 9. 146. There. We have a base converter. So in our case, we just want to store zeros and ones. So if you want to change this to base 2, we just change it to 2. Change this to 2. All of this to 2. So give me a sec. Okay, there. Is that allows the digits? Let's for example, 6. 6 is, oops. 6 is, or for example, 7. 7 is, says here when we convert it to base 2, it's 111. And if we try it here, 7 base 2, 111. So now in our setup for trying to make an 8 squared type level, if we want to make 111, or how do we, well, now we know how to do each different digit, but how do we go through each digit one by one in a very efficient manner? We want to input 7 here, 7 to our system, and then somehow it's going to first give 1, then goes to the next tile, give 1, the next tile, 1, next tile, 0, and so on. So how do we do that? So if you think about it, whenever we want to move the digit, move on to the next digit, we just divide it by the base. For example, when we went in our base 10 example, We got the second digit, we divide by 10. We want the third digit divided by 100, or in other words, we divide by 10 two times. And you can extrapolate that if you want to go to the other digits. You just divide it by the base that number of times to get that number of digit. So let me try to make a better example of how that would go about. Example, we have 7 here. We have a actually let me fix this a little. It's causing a few bugs. So wait, this is basically the same. This still basically rounds down. So you want to divide it by different, or we want to divide by different powers of 2. We want to divide by 2, or if you want the first digit, you don't divide it. If you want the second digit, divide it by 2. If you want the third digit, we divide it by 4. The next we divide by 8, 16, 32, 64, and so on. That's what we want to do. So one simple way we can do that is that we have this number here. We can start it divided by 1. Gives 1. Now if we want to move to the next step, for example, we can just double the number that we're using to divide it by. For example, 1, we can double the value of this counter by adding the current value to itself. So like connect it like this way. When I press A, the current value of the counter gets added back to itself. So it basically multiplies itself by 2. So 1, 2, press it again, becomes 4, 8, 16, 32, 64, and so on. And if we look back here, for 7, you get, for first digit, we're just dividing by 1, so we're not dividing by anything. 1, next digit, 1, next digit, 1, 0. If we see more complicated numbers, like for example, 57, what's that in binary? So it says here, last digit is 1, then 0, 0, 1, 1, 1, 0, so on. So let's double check that. So if it's 57 and base 2, that's 100111. So there we have it. So whenever we want, so we can just use this similar system, same as this, in our a squared over 2 setup. So whenever the launcher moves to the next position, we just activate this to change the number that we're using to divide this by. And then it should go through each of these digits one by one and activate the launcher at the correct times, small different levels. So by just using one number, we're now able to tell the launcher the positions of a number of blocks just using one nodon. And while we use a few nodons to do that calculation, and say for example, if we store like 20 different tiles in just one big constant, you think of like, for example, 22 tiles and one constant. If we had 2 constants, we now have 44 tiles. And 3 constants, we have 66 tiles. And yeah, we're still using the same setup. So now, basically, like earlier, we only have like, in this example, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1, 9 nodons to store 20 tiles. It's already pretty good. But since our system is like very flexible, and we can just change whatever numbers we. Now we put another nodon here, a different number. If it's also storing 20 tiles, now we're storing 40 tiles in only 10 nodons. And now we're storing 60 tiles in only 11 nodons. And we go even higher, or the more node constants that we store, the more efficient it becomes. It basically like goes towards a cost of around 1 nodon every 20 tiles that we store. So let's go back to the 8 squared over 2 setup and try to remake this. Okay, so now we copied our setup from before. So this is the number that we want to print out in binary. This is the same module setup. This is a divider setup that moves for each digit. And now I simply just connected the timer that activates the teleporter whenever the block moves to this thing that multiplies the counter. So every time, imagine every time the dice moves, this counter gets updated to the next value, which means the output of this digitize gets updated to the digit of whatever we're reading, which is being shown in this number object. We can see it live. For example, here, we're trying to read the value 13. 13, so the first digit. So yeah, 13 is 1101 in binary. So when we send it 13, when we send it 13, it printed 10. Yeah, it printed the digits one by one in order of the number 13. And if we set it to a different number, like say 286, I don't know what the binary of that is. Let's figure it out. Yeah, that's there. So the binary of 386 is 1100000010. And that's a first part. So yeah, now we're able to use just one number to tell the launch nodon the information about a big number of tiles. So the next step you might think is, okay, we have 64 different tiles here. Let's just put one massive number that has 64 digits in binary and just put it here and we'll be all right. Now, theoretically, that's what we should do, but in Game Builder Garage, we encounter a problem. So the problem is these constants. So the constant can only go up to 1000. So if we want a digit that's like 64, or if you want a number that has like 64 digits in binary, that would be a number that is 20 digits long in base 10. We need to put a 20 digit long number here. And that we can't really do that here since, like, for example, constants, we can only put 1000 there. And see, every node on can only put a number up to 1000. We can go kinda a bit, or we can do a clever thing here by using the decimal points. Like for example, we can use 123.4567 and then, or put it 456. We can use that and then just multiply it by 1000. See here? Yeah, sort 123.456 and we multiply by 1000 to get 123456. So here we get a 6-digit number, but a 6-digit number is still way not enough to make a 20-digit number. So in Game Builder Garage, we have to make a compromise. We can't store an entire level using just one nodon, unfortunately. So in this system, or in 8 squared over 2, I was able to store it using just, or I was limited to, well, using this technique. I was able to store 21 digits, a binary or a number with a binary representation with 21 digits in just one quote unquote constant. So for each level, I had to use 3 different numbers. Actually, now that we mostly understand how the generation here works, here I have a pretty neat setup here which shows all of the numbers in the original 8 squared over 2. Don't be too overwhelmed. For now, let's just focus on this number 1. So for level 1, I stored the number 263,200 to generate the level. So we can see this move one by one. So this uses the same decoder setup that we use. So it has a dice, and the dice moves using a teleporter. So let me, yeah, here. Moves like teleporter each time. And then you can see each step, it checks the next digit and checks if it's a 0, it does nothing. And if it's a 1, it generates a block. So using the number 263,200, I was able to make this first part of the level. Now, in 8 squared over 2, I only had 64 nodons to work with. So if I wanted to make 32 levels, and I only had 64 nodons, even with the system that I described earlier, like if I had 21 blocks per level, or 21 blocks per nodon, that would mean we need 3 nodons to fill up the entire level. And if we had 32 levels and 3 nodons per level, that would still be 96 nodons. So we're still way far away from our target of 64 nodons of efficiency. So for 8 squared over 2, I did something tricky here, wherein instead of using 3 numbers per level, I just used 1 number. You might be thinking, well, you just said earlier that to make a 64-digit number in binary, we would need a 20-digit number. But here we're just using 263,200, which is just 6 numbers. So how did I achieve it here? So in 8 squared over 2, what I did is actually just use this number to generate this first part, and then when we move to the next part, we just use the same number again. So actually, I just used the same for each level in 8 squared over 2. I just used 1 number and used it thrice to generate a single level. Actually, that's why if you've played 8 squared over 2 before, why each level looks so weird. They look randomly placed. It's not like, doesn't feel like it was designed by a human. That's because to make this game, I actually just looked for random numbers and put them into this system and made the launcher print the digits 3 times in a row. It just shows the numbers that just so happen to make levels that look like levels. That's why it looks so messy. So here, for example, if you go back to the start of this, so here, when the level is finished, you wouldn't actually think that it is just 3 things repeated at the same time. But if we watch it one by one, this is the first part. It goes 2 spaces, block, 2 spaces, block, or yeah, 2 spaces, block, 2 spaces, block, 1 space, block, 4 spaces, block. Does that. If we follow it step by step, yeah, I'm actually just using the same number again and again. And it just coincidentally just happened to line up to make this sort of interesting looking level. So yeah. For example, for level 4, I use 788, which is this configuration. And repeat that twice, it generates this. And so on and so forth. Now, when we look at the actual code of a squared over 2, you will notice I only used 16. So actually, these are the maps that store the numbers. I just used 16 nodons to generate to store the numbers for all the levels. So for a squared over 2, I did something a little tricky with it. Actually, for each level, you could notice that I have these two numbers on the side. So far, for each level, for levels 1 through 8, I'm just using this first number. Then once we reach to the this level 8, once we reach to the 9th level, you will notice that level 9 is using the same two numbers as level 1. For level 9, so for levels 9 to 16, I'm using the second number. So these are going to be the same. Number 1 is going to be the same number that we saw earlier for levels 1 through 8. So for levels 9 to 16, use this second number. Okay. Levels 1 to 16, we use 16 numbers. Now the question would be, you said that this game has 32 levels. If you only had 16 numbers, level here, we're going up here. Okay, we're back to level 17. So level 17, we now have the same two numbers that we used for level 1, and this was the same number that we used for level 9. So now we already used them. So how are you gonna make 16 more levels using this? Here, we're gonna find out why it is weird system, why I have these two numbers for each level. So for levels 17 to 24, what I did was I used the first number to generate the white tiles, and starting level 17, I introduced these black tiles, which are generated by the second number. So if you think about it, well, this is still the same number that I used for level 1, and this is still the same number that I used for level 9. And if you paid attention earlier, these white tiles are exactly the same as the tiles in level 1. And these black tiles are also exactly the same as the white tiles in level 9. So that's how... So I used 16 numbers. So those 16 numbers were used to generate levels 1 to 16 individually. And also, I reused the same numbers to generate levels 17 to 24. So by that, I didn't have to make more numbers. I was able to reuse the same numbers, so I didn't have to use more nodons to make more levels. And let's show level 2 here, or level 18 here. So this number is the same as level 2. And this number is the same as level 10. We combine them and we make this unique looking level. So the white tiles are exactly the same as level 9, or as level 2. The black tiles are the same as level 10, and we combine those two to make 8 more levels. So we did the same thing for level 19, level 20, level 21, and level 24. You know this? Yeah, earlier level 3, this was open, we'll jump through here. But now it looks like an entirely different level because I used a different number, I pasted a different number on top of it to add more tiles. And it is, yeah, I just randomly chose numbers which just so happen that when you combine them, they make some interesting levels. Now, your next question will be, okay, you did for 1 through 8, you used number 1. For 9 through 16, you use number 2. For 17 to 24, you use first number to generate white tiles and the second number to generate black tiles. So what happens in level 25? So for level 25, what I did was I just flipped the two numbers. So now in level 25 to level 32, I use the second number to generate the white tiles and the first number to generate the black tiles. So if you remember from earlier, if we ignore the color for a second, the placement of these tiles are exactly the same as the placement of tiles in level 17. But now, I simply inverted the placement of the white tiles and the black tiles. And yeah, again, I just randomly chose numbers that just so happen that when you invert the two colors, they also would make very interesting levels. So the same thing happens for level 26. So there's the same numbers, the same two numbers in levels 2 and 10, but I just inverted the colors. And that goes on all the way up to level 32. So basically that's the story of how I was able to make 32 levels in only 64 Nodons. So when we look back in our original game, or wait, this is the game that we were, original game, here we go. The original 64 Nodon game. When we look here, these are the 8 numbers for levels 1 through 8. These are the 8 numbers for levels 9 to 16. Then for levels 17 to 24, I just use 2 of these numbers at the same time. And for levels 25 and up to 32, I use the same 2 numbers to generate different levels. I just use different colors for each one. And like all of this logic on the left and on the right are just to select which numbers are going to be sent to our decoder here. And then this decoder is basically the same thing that we made earlier. So this is the, yeah, you can see here something similar. This is the thing that divides or changes which digit is being read. So this just runs through 1, 2, 3, 4, and so on very, very quickly. Since the thing I made here is much faster than the thing we were doing earlier. And this goes through, is that this does a modulo. So this is quite a bit different from what we did earlier, but it's just a bit more efficient, but way more complicated way to do it. But it shaved a few nodons. So yeah, but the concept is still the same. This just divides it by 2 a number of times. Then this does modulo 2. And then we send it to the launch objects to tell it whether or not to generate a white tile or a black tile. And then we activate the teleporters and V teleporters each time whenever we need to generate them. And here's it in action. Yeah, just to recap, let's look back to the generation level. You can see everything that's going on here. So level 1, you can see like it shows everything that's happening in the level. So to choose, or to choose which numbers are being shown, I just use the last 3 digits of the level that we're on, or the index of the level that we're on. So this changes after every level you finish. This just goes up, and these I use the last 3 binary digits of the number to choose which 2 numbers to show. So for example, here when we go back to level 9. So level 9, this goes back to 000. For 000, I choose 263, 200 and 1052. We go back to level 1, it's also 000, same 2 numbers. And this goes from 0 to 7 every 8 levels. It just loops, that's why we're able to reuse the same numbers every 8 levels. And then these different numbers just determine how, or if we're going to use the white tiles, or we're going to use this, the first number for white tiles, second number for white tiles, or first number for black tiles, second number for black tiles. And it just shows the current row and column and position of the dice. This shows which bit that we're on the current number, which number we're using, and so on. So that's basically how 8 squared over 2 was made. So now after 8 squared over 2, I just mentioned it offhand. So after 8 squared over 2, I actually made this extra version, which is 8 squared over 2 version 2. So this is basically the same level, or the same game, but I just added these death counter and a timer, and a bit more pizzazz and a bit more UI and stuff, just to make it look prettier. This is exactly the same gameplay, but like understandably, the 64 Nodon one is very bare bones. So this is just to make the experience of playing through the levels much more better. But yeah, it's just mostly a visual upgrade, and I limited myself to a 256 Nodon limit for that one. Then recently, I also made this improvement here. So 8 squared over 2 times 2. So actually, in the original idea for the Dojam, I was actually planning on making 64 levels using only 64 Nodon, but as you saw, I was only able to make it only 32 levels with 64 Nodon. So after a few years, I went back to this project, and with all the stuff I learned in Nodon shaving and different techniques, I was able to finally finish the ideal product that I was working for original game, and now I was able to store 64 different levels in only 64 Nodons. So it's mostly the same, just a little bit more trickery with the stuff I did in the generating the levels. So what I did was I just blocked different exits. That's actually in the original game, you would notice here there were 3 different exits for some reason. So actually, I also chose the levels with that in mind. So I wanted to make sure that each level has at least 2 different exits, because I was planning to, like, there's 32 different tile organizations. Yeah, there's 32 different tile organizations. So the way I was planning on making 64 different levels was by reusing the same levels, but now changing the exits. So like I was planning, like, for example, this configuration, this was one level was just gonna have this exit, and another level was just gonna have this exit. So the way that you go through the level is different, so that it will be technically making 2 levels by using the same level. So that's what I did in 8 squared over 2 times 2. So I was able to shave a few more Nodons in my original setup before, and I was able to use those few Nodons to implement a way where, yeah, I was able to dynamically block, for example, block this exit for the first 32 levels, then block the other exits with other 32 levels. So you're going through the same 32 levels twice, but going through different exits. So that's how I was able to make 64 levels in 64 Nodons. One last thing about the making of this 8 squared over 2 is how do I generate the same game each time. So it's here, generate level 1 here, and like I just destroy the printer, the decoder, the launcher thing whenever it hits the end there, and whenever I hit the next level, everything's back to normal, but the thing number is changed. So what I do here is basically I just use a game swap to swap back to itself, to the game itself, and then the number that I send to the game swap is the current level. So for example, if I send, well, yeah, for example, right now it's set, this number is 0. So if it's 0, it's going to spawn level 1. Then if it's 1, it's going to spawn level 2. If 2 is going to spawn level 3, and so on. What I did was I just send the current level into the game swap. Then when it does that, it increases this counter to a different number. So whenever it's swapped, it restarts the game. But now the value of the counter is going to be different. So how the game is going to be decoded is going to be different. And so here you can imagine right now the counter is 0. And now I send the 1 to the counter, to the swap game. And now it's going to become 2. Then when I send the different number, 3, and so on. And actually in call that in a squared over 2, I actually put a secret Konami codes here. Like I put the Konami code. So yeah, unlock a special mode, and I can just increase or just send a specific number to the game swap, and this automatically sends me to that level using that same concept of like the level is just whatever the next level that you get sent to is just whatever you sent to the swap node on. And yeah, I can just use the Konami code there to send it to whichever level I want. And yeah. That's about it for 8 squared over 2. So the next project I made after 8 squared over 2 is actually 8 squared level maker. So here I was mostly inspired by Scrubs' balloon game. So if you're not familiar, Scrubs, programmer named Scrubs was able to make a game where you can share your own runs or levels. I was very amazed by that, and thinking about the games I've done before, I realized that I could use the same concept to make a sort of level maker for 8 squared. So, for example, if I make a level here, so placing random blocks, in this game I can go to the share mode, and when I play the level, it's gonna generate a code for me. And then what you can do here is, if you have the copy of the game, you can put this code into your game, and kind of like Mario Maker, you'll be able to play the game that I just made here. So how was this possible? So if you let's go back. So for example, if I try to load this level again, you will notice that the way that the game is generated is the same as what we did in 8 squared over 2. So there's a zigzagging block, and then it just timed correctly where it will know when it should send a 1 or when it should respond a block or not. But here, I actually just basically made the same thing, but I kind of hidden it a little bit using this code system. So this code is actually just one big number. So this is actually, I was saying earlier, to store a level you would need a 20-digit number. And to store a level using just white tiles, you need a 20-digit number. And if you want to store black tiles, you need another 20-digit number. This is that number. So you might be noticing it's not just numbers, there's also letters here. But the concept is still the same. This is actually just these numbers, or these characters that you're seeing here is actually just in base, let me count this again, base 24. So what that means is each digit has 24 different symbols. So since we're going over base 10, that just means that whenever we go over or after 9, we just use letters instead. So actually, when we you try to read this, or if you try to convert this to base 24, or this numpad, this digit goes to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and so on. So I'm actually just using the letters as substitutes for numbers. And I guess a better way to showcase this is by going back to the base converter. And if we increase the base to like a much higher number, yeah, as I said before, base 24, this is what's actually happening in the game. So like you can imagine, each of the characters in the code that's generated is a different number. And it's just one massive number that's like 24 digits long. And each of that number and each digit can go up to 24. So for example here, like when you convert that original code back to base 24, for example, here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When this goes up to 10, in the UI in my game, 10 just means A, and 11 is B, it is C, D, E, F, G, H, I, J, K, and so on. So I just use letters to make each digit have more possible value. And well, now if you remember earlier, like if we have something in base 10, if we make the base smaller, that means representing the same number would use more digits, since we have less symbols for each digit. But if we increase the base over 10, up here I'm using like a bigger number. So in base 10, it uses 3 different digits. Let's get a better example. In base 10, this uses 3 different digits, but in base 24, this just uses 2 digits. So yeah, that's the only reason why I use letters here, because or why this is in base 24. Because if I use base 10 here, there's just gonna be like 50 digits, and that's way too much for people to copy. So by converting it to base 24, I was able to make the codes a much more cleaner, and yeah. That's how that's basically how the level maker works. They have this cursor which moves around and like converts this level into a number, and then converts that number into this base 24 symbols thing that I have. Then when someone copies it and puts it in their own game, the game then looks at this number, converts it back into like each digit having very different digits, then use that number to generate to make a one very long number to send to the launch Nodon, and tell the launch Nodon when each tile would be activated or not. That's basically how the level maker works. I won't go too much into how the rest of the level maker works. That's another topic for another day. So now let's finally move on to 8 squared. So in 8 squared, you notice that the levels are quite a bit different. They don't look randomly placed. For example, here, level 1 is literally shape of 8 squared, and it doesn't look like the same things being copied again and again. So how the numbers are encoded here are a little bit different. So here, so if you remember in original 8 squared over 2, 8 squared over 2, where's it? 8 squared over 2. we had one number dedicated to white tiles and one number dedicated to black tiles. But the only reason I did this here was so that I could like use a trick where I could use one number for just generating levels 1 to 8, another number for levels 9 to 16, and so on. But in the actual A-squared game, it would be inefficient to require two different numbers to generate, or yeah, use two separate numbers to generate black and white tiles. So what I did for 8 squared was actually, instead of using base 2, which was either 0 or 1, instead of using base 2, I now just used base 3. So what that means is, in base 3, the numbers can now be 0, 1, or 2. So the reason I use this is, by just using one number, instead of using two numbers, I'm just using one number now. I was able to store whether or not a tile is black, which is 0, white, which is 2, or black, which is 1. So just using one number, if I code it in base 3, or if I interpret the number in base 3, I'm now able to store the entire thing. All the information of the white tiles, black tiles, and empty tiles. And the decoding process is a bit the same. So yeah, instead of dividing it by 2 and then doing modulo 2, now I just divide it by 3. If I want to get a second digit, divide by 3, modulo 3 to get the third digit, divide by 3 twice, then modulo 3. Here divide by 3 4 times, modulo 3, and so on. And I actually made a diagram here, or a game here, which showcases the level generation for 8 squared. And here you see there's a number, and we convert it to base 3. And here it goes through each of the digits of the number. And you show here whenever it hits a 2, it spawns a white tile. Whenever it hits a 1, it spawns a black tile. Now the encoded numbers here is the actual number that I store, or actual number that I send to the launcher Nodon. So here I just divide since the Nodons, or the maximum number that I can put in constants, is 1000, I had to divide the number by 10,000 to store 7 digits. So it's actually storing 2,601,437. So 7 digits. But they can't store that in a constant, so I had to divide it by 10,000 to show this instead. So what this base 3 representation is, the base 3 representation of 2,601,437. Now since I'm using base 3, I'm able to store only 14 tiles now. It's no longer the 21 tiles that I had for a squared over 2, since it's a squared over 2 was in base 2. So now in base 3, I'm only able to store 14 tiles. So in 8 squared, now I'm using, you can see the encoded number change here. So for each level, now I'm using 5 Nodons per, or 5 numbers per level. So since each level here is now handcrafted, so if you remember from a squared over 2, each level was just a randomly chosen number used 3 times in the same, used 3 times repeatedly to generate a level that kinda looks playable. Now here, I specifically chose these numbers to generate each set of, each part of the level specifically. So since they're handcrafted, I had to use 5 unique numbers to generate the entire level. You can see here it goes through the 5 numbers. Let me show it again. So the first number is this, 253, and so on. The next is 0.724. The third number, then the fourth number, and then the fifth number. and this is the next number for the next level. So yeah. Another thing to note here is the spawn and exit positions. So in a squared over 2, the exit or the spawn was always on the bottom left, and the exit was always in each corner. So for here, I wanted to be more flexible in where the spawn and exit could be. So I also needed to store the information on where the spawn and exit are in the encoded numbers. So actually, when it was in the very first encoded number, in the very first encoded number, I store the spawn and exit in base 64. So that means there's 64 different values it could be. And then we snuck in a few more base three digits for the tile. So for the first constant Nodon, I stored this two numbers. So you can see 54, 14. So the first Nodon there, 54 and 14. That's saved into memory. And then the dice keeps track of which position it's in. And whenever it hits these numbers, it's gonna teleport the spawn portal and the exit portal to its current position. So you can see it in action again here. So right now, the spawn and exit are here in the bottom left. It hits 14. It sees the save number here and sends the spawn there. And then once it hits 54, see that? There you go. It teleports the exit from here to there. Now, and this actually like was the number of digits was actually perfect with this kind of system. So I mentioned earlier that I had 5 numbers per level. So 4 numbers are dedicated to 14 tiles each. So 4 times 14 is 56. So the 4 numbers store 56 tiles. Then 1 number stores 6 tiles, which that's equal to 62 tiles. And then the position of the spawn and the exit, which are the last 2 tiles. So in total, using this system, I was able to store that position or the data for 64 tiles in total, and using only exactly 5 constants. So that's it for the generation. So if we do the math now, in 8 squared, in the full 8 squared game, I use all 512 Nodons, and there's 64 levels. So I mentioned earlier, in every level, I used 5 numbers. So we have 64 levels and 5 Nodons per level. That's 64 times 5, 320. So we have 512 Nodon available. But for 8 squared, yeah, I only have 512 Nodon to store all 64 levels and 5 numbers each. I used upwards of 300 different constants. So each of these maps are actually just constants here. So you zoom in, there are maps, and you can actually see the numbers stored here. And like if you watch the game when it generates, you will notice that it activates each of these maps for each number that it needs to be activated. I keep mentioning earlier that I use like 5 constants per level. I mean, look, here it is just a bunch of maps. And like, what the hell are these settings? How does this store 1 constant each? So let's try to think about it. Where's the level that we were making? 8 squared, there we go. Let's think about it. For example, For the first const or for the first number, we want, for example, 123.46. And after that number is done, we want it to change to, let's say, 289.65 or 653. Let's say that. Or just, yeah, 289.65. How would we do that in efficiently in Game Builder Garage? So for level 1, let's say, okay, let's just put this. So let's just say whatever the output of this calculator Nodon, that's the number that's going to be sent to our decoder here, which sends it to the launcher. So we want the number to start from 123.46. So let's do that. 123.46. We have a counter here which says the current level. Let's remove this. Counter here that says the current level. Example level 1. You want in level 1 the output of the number here to be 123.46. What we can do here is we can put a map and set it to compare mode. And set it here to 123.46. And what this basically does is if the input is equal to or greater than 1, it will send 123.46. There we go. Now let's say go to level 2. How do we change this number to 289.65? Well, what we can do is, well, we already have 123.46. Connect this here and move this up. What this will do is, let's show this here. What this will do is, or if it's 1, does nothing. It's 2, gives nothing. So this basically means if the number is greater than or equal to 2, it will output this. And same here, it's like, this is for 3, 4, 5. So let's just show it. It's like 2 doesn't do anything. 3, nothing. 4, nothing. 5. There you go, it shows up. So this is just a system to send a specific number when a number is greater than or equal to a specific number. So now let's move back. So 2. So we want, if this number is 2, we want it to become 289.65. Well, we already have this 123.46. But if this activates when this goes beyond, or when this becomes equal to or greater than 2, we can just add whatever we need for this to become 289.65. So if we do the math, 289.65 minus 123.46 would be 16619. Try that. 166.19. So if we add it here, so when it's 1, it's 123.46. When it's 2, it was 289.65. And we can just repeat this on and on. So for example, if we want the next number to be like 1.00, then what we want to happen is if it's 3, the 3 nothing changes since it's not 3. Once it hits 3, we want this to go down from 289.65 to 1. So we subtract it by 288.65. So that's 288.65. There we go. And if we make this 3, it becomes 1. Then it's a bit easier for the next a map. Say this is 4. We want it to become like 10. Level 4 is 10. So, oops. Oh, I forgot. Yeah, there we go. Level 4 is 10. So it's level 3 is 1. One more. It's 10. And yeah, basically with this kind of setup, we can use one map for each number. Yeah, for each number, for each different number that we set it to, it will output a different number in the output. So yeah, by using this setup, I was able to store, or each map stores one number basically. And by using 320 maps in 8 squared, by using 320 maps in 8 squared, I was able to store the 320 different numbers that I needed to generate the 64 levels. You can see here, like, this is a counter that says the current level. It goes to wormhole A. You can see wormhole A just goes through the input of all of these maps. Then all of these maps are just added into these additional nodons, and all of these additional nodons are added together, since we're adding 320 things here. So add these a lot of nodons to add them together, because each nodon can only have 16 inputs. There's 320 inputs here. So all of them are just added together into here. And yeah, the sum of all of them is the number that we want. It's the encoded number. And then we multiply it back up to a full number. So yeah, for example, in this case, the number is 326.326616. And yeah, and we use that number, we do the decoding thing, and it spawns all the stuff. Now, one more thing that you might be curious about is, well, if you look at this map array, there's 3 weird gaps here for some reason. Let's look at these numbers. So this is the map for number 36, and then it skips all the way up to number 40. So it skipped 37, 38, 39, and went to 40. Then same thing happens here. There's 41, and 42, 43, 44 is missing. So 45, and we have the same thing here with 86, and 87 to 89 is missing. So what does that mean? Or why are they missing? Let's think about what would happen if, for example, map number 37 is missing. So if map 37 is missing, so let's say we run the level generation. So it takes, so 36 here would be the second map in a batch. So like, if you remember in the level generation part here, so each level has five numbers. So number 36 would be the second number. So number 35 stores the spawn and exit and the first 6 tiles, while 36 would store the first, or the 15, or the 7th to the 20th tiles. So what would happen if the map after 36 is missing? Now what that would mean is, if the map after 36 is missing, so like, we say at 36 we have a specific value x. When it goes to 37, since there's no map here, nothing gets added to the total, so the number stays the same. So if we go back to the perspective of the level generation, like what would happen here is, if, for example, the third map of this level was missing, it would first start with 2530115, then 0724, and after this one, it would still be 0724 because there was no map to add more numbers to it. And what would happen essentially is what I basically did in the original 8^2, which is I was using the same number to generate multiple segments of the level. And by doing that, I was able to save 3 nodons for each level that I did that. So since there's 5 nodons per level, the first node, the first map stores the spawn, exit, and the first 6 parts, or the first 6 tiles, and then the second map would store the number that will be used for this the one map. I only use one map to do the rest of the level instead of 4 maps. So in that way, I save 3 nodons, but I'm forced to use the same number for those 4 segments of the level. So now, if you remember from a squared over 2, when I did that, the levels look pretty weird. And yeah, that's the main reason why I was only able to do that 3 times in 8 squared, because most of the levels that I tried to do that ended up looking pretty weird. But let's visit those levels that I was able to pull it off. So the first level here is Cliff, level 8. So if you look here, like the first 6 tiles here is empty, and like the start is over here, and the exit is over here. And if you pay attention to the patterns on this cliff, you'll see that the pattern is white, black, then 3 white. And if you pay attention to the way the path that the launcher moves, you see the pattern repeat 3 more times. So white, black, 3 white, and it goes around here, then white, black, 3 white. Then it goes around here, then white, black, 3 white. Yeah, that's actually, when I was making this level, I specifically was looking for a level where I could do that shave, and this is the best level that I could find that does that shaving technique that still looks like a decent level, especially with these black tiles over here. The next level I use that on is level 9, which is pure. And for here, you can see the pattern here is white, or empty, white. So if you look through all of these, the rest, you have white for empty, white, then white for empty, white, then white for empty, white. And the last level I use that on is, look for it again. Here, minimal. So here, it's pretty minimal, and the pattern is just white. So first iteration is white, the next one white, and that's the entire level. Yeah, so that's why there are gaps in the map array. So one question you might have is, well, now that I understand what all of these maps do, so each map like encodes a number, and like it adds a specific number, the exact number that the decoder would need to generate the next part of every level, and it needs to do that 300 times. Well, for these maps, did I place all of these maps manually, and like for each and every level, like every encoded number, I need to figure out the exact number on my own and calculate it, and then put it on a map based on this game, and then like do that 300 times? No, actually I use quite a bit of automation to pull this off. So let me run you through the process that I went through to make a level. So if I was gonna like add a new level that I wanted to be in the final 8 squared game, the thing I would do is to like make a level in the level maker, like the same level maker that's uploaded on my program ready right now, and then I'll test it out. So the physics in the level maker version 3 is exactly the same as the physics in 8 squared, like the hit detection and yeah, everything should be identical. So it's a perfect testing ground for testing if how good a level is and if I like it. So for example, I made this level and I decided after testing it out I want to add it to the list of levels in 8 squared. Well, the first thing I do is I will just do this clear thing. So I'll click it first, and then I will get this game ID in base 32. So after getting this game ID, I would copy these characters and then put them in a list on my computer. So I know, since I was the one who encoded this, I know exactly how to interpret this and like convert it back into a 8x8 grid of data. So now I have a list of all the levels that I want to be in 8 squared. So the next step I did was I put that list into a script I made, which calculates all of the constants that I would need in order to make each of those levels one by one. So yeah, it just does all the calculations on its own, and I also like encoded it how the the launcher moving thing decodes stuff, how that everything is calculated. I factored all that in and just wanted to get all the constants that I needed. And after I get those constants, I then calculated all of the map values that I would need for the eventual map array that we're gonna have here. So I had the script to calculate every single number in order from this map array. So I would generate a list of all these numbers. Then after that, I put it into a script I made. That list of different map values into a script I made for the Arduino. So actually by this point, I had already developed a script for the Arduino where I can like put some lines or put some functions into the Arduino script, and I can tell it like to create, for example, create a map with this kind of settings, with this kind of settings. Just all the settings are just variables in the function call. It'll make a map, and I can do very long scripts that could like make entire blocks of code just using the Arduino. And yeah, for this project, I made a special script which specifically takes in that list of map values that I wanted and places all of the nodes automatically. So actually, I still have that script on my computer, and here to better showcase, I'll just run it now. So here's the Arduino code running. So at the very start of the Arduino Nodon creation code I have, it always starts with a location sensor, so I can choose where in the program this music can start. And now it's off. Yeah, now it's running. So at the very start, you're just gonna put all of these wormholes where all of the numbers are gonna be, or where the input of the maps are gonna be coming from. Since like I need to send that counter input, the index number, to all of the maps. Then also puts these additional nodes where the sum of all of the numbers are going to be used into. Yeah, you can see here, it just does all the maps automatically. So it keeps track of which numbered map is on right now. So like, for example, this next one is going to be the 7th map. So you can see the input range set correctly there. And it just goes through each one in my list of values that I found with the other script. Now basically, yeah, so the whole process is I just create a list of all the codes, of all the level maker codes for all of my levels that I want to add to the 8 squared. Then put it on a script, and it just do everything automatically. Just place all the maps automatically. And after this was done, since like everything's connected with wormholes, I can just test it out and play the game. Actually, I was quite thankful that I did it automatically this way, because actually there's been a few times where like after I first implemented the script and like made a full list of 64 levels, there were a lot of levels that I still wanted to fix or improve or move around the list after playtesting it for real, like in order in all 64 levels. So if I didn't do automatically, I would have to redo all of the map values by hand again. So, but here, all I just need to do is just go back to the level maker, like redo the level, get the code, replace the code in my list, and rearrange the codes to whatever I want, and then put it back in the script and run it again. Oh, and I kept doing that a few times until I finally got to the final iteration that we had. Oh yeah, that's how a map array in 8 squared was built. And you can notice here is it's actually even the script does the shrinking part because like everything, all of the nodons won't fit if they're the normal size, and they're also connected like in this configuration, and it's exactly how they're connected in the original game. So I basically didn't touch after the Arduino place nodons here. I just basically didn't touch it and left it as is. Yeah. So that's it for that. So the next thing I want to discuss is the save function of the game. So for example, if you're on a specific level, say, let's go to level 2 first. Go to level 2, say like you want to take a break, and press down R button, and somehow it will send you to this level select game, and remember the latest level that you finished with this code G60646, and let's just confirm. If we put G60646 here, you will see that we are able to load the same level or the same save file. So how is this possible? So let's look into the code. So it's actually pretty simple. So when the R button is pressed, what happens is basically I just send the current level that their player is in currently, plus the number of deaths times 66 to the game swap. So how does that make sense? So basically what's happening is that like, if we go back to the base converter here, it's basically as if I'm sending a number that's in base 66 to the level select. So for example, if for example I'm on level 5 with 0 deaths, it's just gonna send 5. And if I am 57 with 0 deaths, it'll send 57. But if I'm like, for example, 3 deaths on level 35, I will just send 233. So the way this encode is just you get this first number and add the second number multiplied by the base, and that's how you get back here. So the number I'm sending to the game swap is basically just this number, which is just the sum of these two numbers. So that's how it's done. And then when it reaches the oops, wrong game. When it reaches the level select, I'll just have a decoder that looks at where's that game swap. Here's the game swap. So I'll just have a decoder. Yeah. But this is just I can use the counter as another modulo. This just does modulo 66, and then this extracts the current level, and then yeah. So for example, so by default this starts at 0, so you have 0 levels unlocked. But like for example, if I change to like 57, if the save thing that gets loaded has a level number of 57, yeah, it's just gonna load on level 57 here. And then I think the number of deaths gets calculated somewhere else here. But basically the same, it's the same thing. It's the same base calculating, base digit splitting equation that I did. And then when going back to they call it again, the main game, example, when I select 3 here, it's just gonna do the same thing in the other direction. So it's gonna send basically, it's not, these are not the exact bases that I use, but it's basically the same as like sending another base 66 number that says the current level plus the number of deaths, and then when it goes back to the specific level, it's gonna load the level that I selected, and then add the deaths that was stored in the level select into here. So yeah, and then the level select. Yeah, we have this code, and this code is basically just that number that we're sending between the two games. So they're encoded in base 32, just like the level maker codes were, just to make them look more pretty and easier to remember and save somewhere for you. And yeah, and if you're wondering how this UI works, how I'm like able to move these around, I think a better example would be to show the level maker, since I'm using the exact same code there. So to do the spinning character input menu UI, let me just show it off here. There we go. Here we have this blinking indicator that I can choose, and when I choose something, it saves it there. So if you're wondering how that works, we can see what's happening behind the scenes when we delete these textures. And maybe I can widen the word wall so that we can see more. There you go. So when I move here, you can see that I actually have this massive cylinder that has all of the characters on it. And then to change what character is being displayed, I just rotate the cylinder by an exact amount. So like all of them are spaced out the same number of pixels, so I just need to move them in a specific amount, and it goes to that specific letter. And when I select a specific letter, like for example here, this cylinder also has a launcher that's attached on it. So when and that launcher also launches a cylinder that has the exact same texture configuration. So when I press it, it's gonna launch a cylinder in that position with that same character that was saved. So that's basically how it works. So I just did the same thing for the level select. And then the actual values are just stored somewhere else inside the code, using counters or other ways to save information. That's the save menu, and like a few more Easter eggs about this level select menu. Like you can see these are the cylinders. So they're moving, or yeah, I'm just rotating them using a counter, a map, and a hinge, each of them. And then the actual new UI, like for example, these are just one long texture of a pixelated version of each level. So it's just all the levels, and I'm just moving all of these using a side connector. And yeah, I just size them perfectly so that they'll just fit in this little square. And these are actually derived from the thumbnail that I use for the main 8 squared game. Yeah, then for all the names, so all the names here are actually any changes for every level, and for this one, I just had I just put one texture for every single name. So for the level select, I still had like a lot of Nodon left, so I wasn't too worried about doing this efficiency. Like this, the way I did this was very inefficient, but yeah, it's not like I was trying to save one Nodons, and yeah, they're selected in this big grid of bullseyes here. So like yeah, when I move from 1 to 64, it just goes along row by row and selects the exact texture for the name that I want to display. I think that's about it for the level select. Now, one more interesting tidbit that's about the how the level select works is okay, when the level select sends a specific number to the full 8 scored game, it's gonna update this counter to move to the specific index that corresponds to the first number for that specific level. So for example, for level 1, the counter should start at 0 so that it's gonna spawn the level using the maps numbered 0 through 4. Then for level 2, it would start at 5, and level 3 would start at 10, 15, and so on. But theoretically, the way this is coded, you could actually just send you could actually make a different game, not my level select, or yeah, not my level select, but maybe you can make a different game and swap to this game using a different number that's not 0, 5, 10, 15, and so on. And what would happen is, instead of loading the level using the 5 maps that I intended for it to use, it will instead load the level using the wrong maps. So for example, if I load it with a value 2 instead of 0, then what would happen is the level will generate using the maps numbered 2, 3, 4, 5, 6, and 7. Or 2, 3, 4, 5, and 6. Which is wrong because level 1 is 0 to 4, and level 2 is 5 to 9. So we're using like the latter part of level 1 and the first part of level 2. And actually, Dalmont figured this out and actually made his own level select here. You can see the code here if you're interested. So basically, it creates the custom swap value that swaps to the 8 squared game, and then makes it load the game. So nothing, I didn't touch anything with the original 8 squared game. This is the same 8 squared game that everyone has access to, but if you send a very specified swap value to it, you can actually make it generate different levels that were not included in the original game. So like here he even played all of these rich levels. There's like 300 of them, and like what if they're impossible or doable or interesting. So for example, here this specific glitch level, here. So it looks like a bunch of nonsense because we're using maps in the wrong order, so they weren't really intended to be like this. But yeah, you can see here we can generate quote unquote lost levels or glitch levels, which is really interesting that something like this emerges from a GBG game. But yeah, most of them are impossible. Like a few of them are like very easy, but there's a few interesting ones there. And also another thing to note is, because of how the game is coded, the game, or whenever the level is cleared, the game just tries to generate the next level using the next 5 index numbers. So for example, if we started a level with index number 2, so it's gonna generate a level using 2, 3, 4, 5, and 6. Then if we somehow clear that level, the next level it's going to generate is still not the correct level, because since it ended at 6, it's going to generate the next level using index number 7, 8, 9, 10, 12, 10, 11, 12, which is still a glitch level. And that's, you can see it happen here. You finish a glitch level there, and now it's going to generate another glitch level here. It just so happens to be also doable, so let's keep going. Here, it's just going to that spot. And now we reach a impossible level. Oh yeah. Actually, if you look back in the Dalmot's glitch level select here, the threads here indicate that. So, like, threads are like, or since it goes in every multiples of 5, when you finish glitch level 16, he marked it as thread 1. If you finish glitch level 16, it will actually go to glitch level 20. So that's what the thread he put here indicates. So it's the next or the level that generates when you move the map index 5 more after each level. Actually, it's just to showcase one cool level. So for example, here, glitch level 42, or that one thinks it's cool. Let's look at it. That is pretty cool. That's an interesting jump. You have the wall jump here and like thread this needle, and, like a lot of black tiles. Very interesting. So yeah. So now we've basically explained everything in the game. Let's just do a recap of all of them and like go through the entire programming screen. So yeah, this part is the map array, which stores all of the constants that we need to generate each of the levels. So each level requires 5 constants each, and that's why there's around 300 plus constants here to store all 60 levels. And yeah, in total it costs 300 Nodons. So if you get rid of that, it's only 200 Nodons. So the rest of the game is basically just 200 Nodon. There's actually, the logic of the game itself is actually pretty simple compared to other games. Like most of the complication is just, or most of the Nodons is just used for storing data. And the actual logic that we use to generate the data is actually pretty cheap. Yeah, so moving on. So next, all of these wormholes are just to send this counter value to all the maps to generate the specific encoded number that we want to generate. Then all of these addition nodons are just to add all of the outputs of all of the maps into our decoder here. So in our decoder, first we multiply it by 10,000 here, since usually our constants are stored in like with a lot of decimal places, so that we can, since the limits of the maps are up to 1000, so we can't use more than 4 digits, so we had to use the decimal values as well to give us more digits to store more data in each map. Then we round it over here, and this part is the repeated division part, which every time when we activate this will change which digit of the encoded number we're reading, so that the launcher can move through each digit as it moves through each tile in the game. That's it. And then here we have the modulo, which just calculates the last digit, or which calculates the specific digit that we need to send to the launchers. And after getting that modulo, the output is either 0, 1, or 2, and we just have these comparisons which send to the white tile and the black tile. So if it's 2, it's going to activate the white tile. If it's 1, it's going to activate the black tile. If it's neither, nothing gets activated. And here I just have something to make the generation a bit faster. So actually, I have a timer here which counts or which tries to remember the last time or tries to remember the cooldown of any launcher. So if any launcher has recently launched, it sends the teleporters into a cooldown so that it can move to ensure that when it moves again, it can spawn another tile. But if the cooldown is off, the teleporters run much faster. And these are just the teleporters which move around the level and generate and places the launcher nodons where we need them to be. And here we have this swap, all of the swap logic basically. So this after when you come from the level select, a specific number here that's gonna come out that has the information of the level and the death count. So the level is calculated using a modulo and sent to this counter here. And the death count is also calculated using a modulo with a map and a counter here. And the number of deaths is stored here and the level is stored here. And as mentioned earlier, the level is sent out to wormhole A to go to all of the maps. And this is just the death count. And for the swap is activated whenever I press the R stick, and it sends the current level as well as the number of deaths through this input. Now, so here's the thumbnails. So this is just a cheap way to do a thumbnail. Just have a counter at 1 and a constant 1 going through it. So at the very first frame that the game is active, this is active because it's 1, then it immediately goes back to 0. That's how it's the thumbnail. So and the thumbnails are actually just it's placed here at -20, so that it's very close to the camera. So when it's close to the camera, it looks bigger, and I chose the exact specific location where it would cover the exact space that I want for a thumbnail. I just have this grid to put lines between each level so that it's clearer when you look at the thumbnail. And just what I did here was a shadow, and this is the actual thumbnail background. And it is the shadow that gets cast whenever a level is being generated. This part is all of the logic for showing the input indicators. So yeah, I just use a bunch of extending objects here to go right or left to show when how much you're tilting the left stick. Then for B, I just have a counter which counts how long I'm pressing the B button. So yeah. Actually, fun fact, the B button for the person Nodon, the shortest jump that you can do is just 1 frame. So it's really hard to do. Like when you, usually I can only do like 2 or 3. I need to really try hard. There we go. I need to try really hard to do a 1 frame jump. And the longest jump is 13. So if you hold it for 13 frames, you can get the maximum jump of the person. So if you hold it any less, you're not gonna get the max height. So there we go. And here we have the person nodon. So the person nodon has a bunch of teleports to it to move it wherever we need it to move. So whenever the person dies, the person gets teleported to teleporter E, which is right around here. Then when we want it to spawn, it gets teleported to the, which one was here? Teleporter G. So this is the spawn. Actually, this block of code is the spawn portal, and this block of code is the exit portal. And there's just a bunch of stuff here because to generate animation. Because if you play the game, the spawn exit or the spawn portal spins every time the person is about to get spawned again, and this one keeps turning whenever the game is running. Okay, and the person here, other things attached to the person here is this launcher, which spawns the cylinder, which acts as the hitbox for the person. So when it gets broken, a signal gets sent here and yeah, causes the death animation and makes the player respawn again. That's the player. And this box just get launched whenever the player gets this quote unquote destroyed to show the particles to make it look like the person got destroyed. These are just the animations for all of the stuff for the death animation and death effects. Here's just texture. And the dice just starts here. So the way I coded it, dice just starts here and it immediately goes up, then there's a zigzag, and then once it reaches here, it gets immediately teleported back to this same position. And then this is the teleporter. So to do the effect where all of the blocks get shrunk down whenever a level is finished, I just use a teleporter entrance with no exit. And if you do that, anything that gets teleported will get shrunk and disappear. That's how I do that animation. And this one is just a simple teleporter and able to cover the entire level. And here, just the two background musics. There's a death counter. This death counter, and this one on the top is the timer. The timer just does a simple modular here as well. And then yeah, here's just a few more sound effects and stuff. Few more other calculations here for the level. And then the rest that we're left with is then we have these two location sensors. So here I'm using location sensors to store constants. So 3 constants per location sensor, since it's more efficient than just one constant. So yeah, that's what those location sensors are doing. And then we just have the game screen and just all the objects covering the walls. So here it is with the walls. Then if I remove the walls, it's just gonna show the actual wall of the world. Yep. And that's basically all 512 Nodons in 8 squared. Well, if you reach this point, I hope you enjoyed listening to this video. Hope you learned a lot. Hope you found it interesting. If you're curious about anything else or want to learn about something specifically, feel free to ask in the comments or ask me on Discord. I'm always open for any questions. I enjoy explaining things like this. And yeah, I was really proud of how this project came to be. Like, I felt like it was able to make use of a lot of things I learned in GBG that I wasn't sure I was gonna able to use, but somehow I was able to coalesce all of these information into this one big project that really felt amazing to finish. Hell yeah. That's it for the programming part. Okay, so for this last section, I will be now discussing the level design that I implemented for both 8 squared and 8 squared over 2. So first, let's start with 8 squared over 2 because actually a few things got carried over from the stuff I made here. So as I discussed earlier when I was explaining 8 squared over 2, for each level in 8 squared over 2, or every 8 levels, there's 2 numbers that I store. So So levels 1 through 8 use the first number, levels 9 through 16 use the second, levels 17 to 24 uses both, using the first number as white and second number as black. Then the last 8 levels just flip the colors. So the first number is used for black tiles and the second number is used for white tiles. So actually when I was choosing the numbers that were gonna be implemented into 8 squared over 2, I mostly just focused on the last 8 levels, to be honest. So it's not like I didn't have much, since everything is like kinda random. It was pretty rare to find levels that were actually playable, much less that were interesting to play through. So yeah, I mostly first focus on what would be decent final levels, or the last 8 levels. What would be the most decent last 8 levels? And once I filtered out like a lot of candidates for possibly good levels, I then look if when I flip the colors, would they also be kinda decent or at least workable. So that's the thought process that I went through for most of the levels. So I mostly prioritize levels 25 to 32. Then after that, I check if levels 17 to 24 would be okay. And then for levels 1 through 16, I basically didn't care how the levels would look like. Since, yeah, you would notice like if you play through it, the difficulty is pretty random. Like for example, here you need to do a wall jump, but maybe like in the next level you just need to walk to the exit, like this one. Yeah, that's because they really didn't put much thought into the first 16 levels. They're practically just fillers. It's just an excuse to say that I implemented many more levels than I did. But the main thing that I just focused on when designing this game was, yeah, the last 16 levels. So let's look at the last 16 levels, or specifically the last 8 levels. So they're mostly the ones that I show. So yeah, this one. So yeah, one more thing. I wanted to design the levels such that there's 2 exits, and I wanted the path to each exit to be unique, because I was planning to make 64 levels and just have the first 32 levels have one exit and the latter 32 levels have the other exit. So I also wanted to choose the levels that would have unique experiences when you go through the level through going to one exit, and if you go through the level to another exit. So you see that here in level 25, where the first exit here is you have to jump up here and then wall jump, and then going to the right, you jump up here and then you need to like do this long jump backwards, forwards, and go to the other exit. This one will come back later. So yeah, when I first released 8 squared over 2, a lot of people actually got stuck at this level because this jump is pretty tricky. Like if you go too high, you hit your head on the black tile, and if you go too low, you won't be able to reach up. So yeah, actually one of the levels in 8 squared I made a level in 8 squared specifically to copy this jump. Now for this level, here I wanted to implement the reverse coyote jump, so I'll go much deeper into it when we go to the actual 8 squared, but there were several tricks that I figured out that the person can do, and I wanted to implement those tricks into some of these levels, specifically the exits going to the top left, and one of them is the reverse coyote jump, which I'll just show like that. But I thought it was really cool that the person only can do something cool like that, or like there's specific tech other than just normal jumping and walking and running. That's why it's level 30. So it's like a niche technique. So I made sure to put that in level 30, and same thing happens for levels 31 and 32. And this one, level 31, I was really happy with how this level came out, because when I was making 8 squared over 2, I found out about the coyote jump that you can do in with a person Nodon. So I really wanted to find a level where it forces you to do a coyote jump, and I found it in this level. That's why it's 31, it's because like coyote jump at the time was a pretty non-standard thing that a lot of people knew, so I had to put it at the end since it was kind of difficult to know that that was possible. Here, coyote jump happens. Here, you need to do a coyote jump to reach that block, because otherwise, yeah, if you jump from here, you won't be able to go up there, and if you go down here, there's no coming back. Then finally, level 32. And level 32 is quite a bit of a doozy. So, in my original intention for this level, I found out that the most difficult trick that I could make the player do is this jump. This jump where you don't have white tile above you, and then the next tile over are both black tiles, and then next tile over is white tile. So you need to somehow cross that gap. And to do that, it's actually possible. So what you need to do is like start from here, then gain some momentum, try to get some momentum, then hit your head on this white tile, and then immediately let go of B so that you don't hit your head here, and then hope you have enough speed to reach from here to this point to this point and barely miss this black tile. So actually level 32 has this jump, and also level 24, which is the inverse of this level. Now that's what you needed to do to reach this first exit. But what's extra special about this level is that the exit is over here. And to reach this exit, what you need to do is do a coyote jump over here. Well, the problem there is to do a coyote jump over here, well, you can't just start from here because you won't have enough speed. So the only way to reach here, that I thought before when I first made this level, was that you start from here, you do the ceiling jump here, do the difficult ceiling jump here once, go up here, and then from here you need to do ceiling jump again, and without stopping right after doing the second ceiling jump, you do the coyote jump from this point and reach the exit. I thought that was just a really cool and extremely difficult trick to force on the player as the quote-unquote final jump of the entire game. I thought it was really cool that I was able to find such a difficult and complicated jump. But after some time, I found out some loopholes. So, for example, actually don't need a running start to do a coyote jump. So actually one way to do this is to just jump, then I can do a coyote jump there. And also one interesting thing I found while playing this game was there's also another cheese strat for this final level specifically. So if you notice, the level doesn't generate instantly. So actually, it's possible to, if you're fast enough, do that. So what happened there was, I jumped up fast enough such that when I reached this point, I was able to wall jump from this block to get some air before this block was able to spawn, so the dice was still around here. And then while I was midair here, the dice passed through and placed a block here, saving me. And by doing that, I was able to skip all of this and finish the level in record time. So actually, even though that kind of breaks the level, I think it's really cool that there's a speedrun strat in my game. I think this is really cool, even though it kind of breaks it. Yeah, so that's most of it for 8 squared over 2. So now we can finally move on to the actual 8 squared game. So here I'll just mostly talk about each of the levels as we go through in level select. So actually, when I was first starting out the game, I first collated all of the levels that people made for the level maker. So when I made the level maker public, I made some forums online and I posted it on different places. And when I thought about making 8 squared, I just collected all of the levels that all the players made and filtered them through the levels that I thought was interesting or I would have wanted to add to the game. So this level 2 here, Simple, which was originally a game made by SquallyCoin 5664, and it was really simple. It didn't have any black tiles originally, and I thought it would be perfect for a level 1 since it's really easy, just teaches you to jump on and off. But as I started programming the game, I thought I wanted the first level to be more iconic, more unique to 8 squared itself. So I ended up making this level, which is title, which is basically kind of acts as like a title screen. Since there's no actual title screen to the game, I just put 8 squared the title as a level, and it actually works pretty well as a first level because it teaches you that you can wall jump through the walls, and the black tiles can kill you because usually most players will just run up here and face plant into the black tile and explode. But yeah, so after I put this, well, the original version of this level had no black tiles, so I had to put extra black tiles here to make things more interesting because I didn't want it to be too much easier than the first level since this already had some hazards on it. Next level is 3 Turn, originally inspired by a level made by Popcorn Ron. So from their level, they just have this one big jump. I thought, yeah, I wanted to teach the player that they can do one big jump, so I copied that jump and then added some more visual flair to it. It's called Turn because it looks like a U. Next level is Cave, made by RetroPop89. I think I copied it block by block. I just thought it's pretty cool. It's like a cave, easy difficulty, a little harder than the other games, but yeah. Next one is Well, by Someone Unknown. Also another decent level. Very simple, easy to know the solution, and has a little bit of difficulty. It's Balcony by Kirby Super. Also visually pleasing. Interesting jumps. And then 7 is Bunker. I think I made this myself, so I just want the player to go around the level and put the exit deep inside. So it's called a bunker. And yeah, mainly I added this to like to pad out the earlier levels with more easy levels. Now 8, already mentioned how level 8 came to be in my explanation of the gaps in the map array. So I specifically looked for a level where I can implement gaps in the map array, and this is what I ended up with. This was the only level that I could find with black tiles that look kind of a decent level. So yeah, and same for Pure. So yeah, so one more thing actually. When I was arranging all the levels, I've kind of decided that I wanted every 8th level to be like kind of a boss level, quote unquote, and every level after that to be a sort of tutorial level. So like, yeah, level 8 is a bit more difficult compared to the other levels because it has this like zebra like stripes in the going to the exit, and then you need to like get some width pretty high. Then number 9, I kind of planned this to be a tutorial level, and this level is kind of a tutorial. I just came upon this look doing the same thing I did for this to shape to find the gaps in the map array. And when I played through it, I realized, this is actually a pretty good level to teach something to the player. So what this actually teaches is short jumps and long jumps. So when you normally play through this level, I think most people are not aware of how the person Nodon jumps are or how important they are. Maybe some people just jump just do the full jumps all the time. But if you just do the full jump, so you, with a full jump, you need to do a full jump to clear this first part. As once you get to the second part, if you do full jumps, you'll never get to the exit. So what this forces the player to learn is that they need to do a short jump like that to reach the exit. So that's kind of the tutorial that I wanted to teach. That's the thing I wanted to teach the player for that level. Alright, let's move on. Number 10 is Dojo. So one of the GBG streamers that showcased my level maker game was Video Dojo, and during his stream he invited a lot of the viewers to make their own levels, and someone submitted, a programmer named Red submitted a level of his face. I thought it was pretty cute, and it would be a nice homage to put the creators, some of the creators, as levels here. And yeah, in the original level, I believe the spawn and exit were right next to each other. They just wanted to show that they drew Dom's face, but like I didn't want this to be like level 1 or something. And I want, since it's not level 1, it's like side in the middle, I wanted to add a little bit of difficulty, so I moved the exit here. So you need to think a little bit of how you're gonna get there. Number 11 is Break. So this was inspired by a level made by Sir Eggroll 991. So I believe in their level, they just had like this jump and like something similar to this part, and I really like this part because normally if you're gonna play through it, you're gonna hit your, if you try to break here, it's not enough and you're gonna hit your face on this black tile and explode. So this really teaches you that, oh, sometimes you need to slow down. You can't, like with jumps like these, you need to slow down and break. The next is number 12, which is Layer. So this was originally inspired by level by Skunktronics. So they had a similar level where like they have these 3 layers. There's something here, there's obstacles here, they need to climb something here, and this hole is the same as well. And I just made change the look a little bit to adjust the difficulty to fit more with the rest of the levels, and yeah, look more interesting. Level 13 is Mirror. This was actually one of the last additions that I added to the game. Mainly at that point I was just starting with aesthetics first and like trying to figure out, and after I do something aesthetic looking, try to add jumps depending on what difficulty I wanted to implement to the game, and yeah, visually interesting, and these jumps look pretty much right for this sets of levels. So yeah, 14 is love, and it's obviously a heart. So the backstory behind this was, when I was making the game, I had a forum and I was regularly updating it with levels that I made, and on February 14 I thought, why not I just make a level that looks like a heart, and this is what I ended up with. And yeah, I adjusted the difficulty to be kind of 14 because I wanted to be in 14. Next one is 15. This is Checker. So this was inspired by a level by Grape Juice TV. I believe in the original level they just had strips of these just repeated, but I thought I wanted to mix it up a little bit. So for this level I took the same idea but made 3 different sections for it. So this first section, you have this safe ceiling. Here you have a higher ceiling, so you need to jump more carefully, and here you have a zebra ceiling, so you need to run through it really fast if you want to do it. Number 16 is Parkour. It's actually one of the first levels I made to promote the level maker. I believe I made it for the trailer for the level maker, and I want to show people that you can actually make pretty interesting levels using this 8x8 format. This one, yeah, pretty difficult at the time. The precision wall jumps, that like consecutive precision wall jumps. And actually when I put this at level 16, which is one of the quote-unquote boss levels, because you have to really you really need to have learned to control how to do the wall jumps here. Kind of like following here, like teaching you how you should manage your wall jumps, and here really testing if you really learn that here. Number 7 is Coyote. So here, a lot of the later levels in A Squared relies on the Coyote jump. So the Coyote jump is, let me just show it here. Coyote jump is the jump where right after walking off an edge, you just technically still have some grace period where you can jump mid-air. So, like for example here, like that. So I couldn't really expect the player to know that the person Nodon can do that. So I really wanted to show them and force them to learn it through this level. So in this level, it looks pretty much impossible if you didn't know what a Coyote jump is. And like, there's no other control, so with this big conspicuous arrow here, they would have no choice but to try what would happen if I press B here. And they will be surprised to learn that, yes, indeed, you can do a Coyote jump in GBG. The number 18, level 18 is minimal. Okay, so level 17 comes right after a boss level, so this is the tutorial here is to teach the Coyote jump. So right after this level, I put this level, minimal, because I wanted to force the player to just use what they learned. So this this level might look unassuming, but when you actually try it, you will find out that if you just do normal jumps, you get stuck here and you have no way to get up here. So I placed it specifically right after 17 so that Coyote jumps are fresh in your mind. And I wanted to tell the player that anytime in the future, I won't put this arrow here. You figure out yourself that you need to do the Coyote jump. And over here, look at here and get stuck. Think about it, and you'll soon find out, if you think about hard enough, that starting from here, you can run off, do a Coyote jump to reach this wall, to be able to wall jump to this white block, get up on top of it, and get to the exit. Next is 19, which is Stun. Not much to say about this. I just wanted to design a level. Like, yeah, there's an open space here, and you need to go down, around, and go up again. I just thought that was interesting. Next up is 20, which is Party. So when Video Dojo was showcasing the levels, or showcasing the level maker, there's actually one popular community member called Disco, and his avatar is a small pixel art made of black and white. So this was a perfect place the level maker was a perfect place for people to make copies or parodies of his avatar. So a lot of people submitted that, and even actually including Disco himself. And actually this was a level that Disco himself uploaded. So, but I think their version was like the spawn and exit were right next to each other. But here, since I wanted to put it around the middle of the pack, I made it much more difficult by putting the starting point here, and forcing this tight jump here, and then this second risky jump here. 21 is Belay. So this level was originally made by Sisters, and what I like about this level was it taught you to save yourself while falling by using wall jumps. So here is one of the few levels where you start, where if you don't do anything, you just immediately die. So here you have to save yourself and wall jump here. Then you have to do the same thing right at the exit. So it's called belay because it's kind of like the belaying thing when you fall down and rock climbing. Number 22 is Snake. But here I also started with the visual shape first when I designed this level. I wanted to make a level that snakes around, like as much air distance covered, or spare to move as much distance covered as possible and not just like do the normal zigzag to make it a little interesting to go around. And 13 is Jagged. This is, but here when I designed this level, I made it specifically to test this type of jump. So this type of jump or requires you to jump off here, and from here do a very short jump to make sure that you don't hit this. So I wanted to give the player this type of jump. So I just built this type of jump 2 times in a row, and after implementing those 2 jumps, I just added some more decoration around the level, and it looked like this, and I thought it looked kind of jagged, so it's called jagged. Level 24 is Shriek. So this is a multiple of 8. So now this is the boss level of this group. And so the tutorial of this group is Coyote Jump, and it follows that the boss level would be a test of your coyote jumping skills. So here I made a level which forces you to do coyote jumps multiple times in a row. So for example, here you need to jump off here and then do a coyote jump here. Then right after doing that coyote jump, you're forced to do another coyote jump right after. Because if you stop here, you lose the coyote jump ability. You need to do a coyote jump and do another coyote jump right after. And do the same thing here. And so it really forces you to use that coyote jump correctly. Next is a 25, so it's another tutorial level. So now this one teaches the reverse coyote jump. The reverse coyote jump is when you do a coyote jump, but reverse your direction right before jumping. So I can show there. So instead of continuing my jump, I can immediately flip my direction by clicking the stick right before jumping again. So to teach that to the player, I copied the exact same setup as the coyote jump tutorial, but now I added this extra arrow. Tell the player, okay, do the coyote jump, but try to hold left this time. And if they do that, they'll figure out that, oh, they can do that. You can do that maneuver and get up here. Actually, there's also another thing that other players do. Like you can actually like scooch off the edge and do this. But kind of fine with that, but I prefer doing this. It looks cooler. Alright, let's move on to the next level. So the next level is Escape. So this level was originally made by a player named Jasper Wordman. So right after the reverse coyote jump tutorial, I wanted to force the player to use reverse coyote jump in the next level. So this level just happened to have one of those jumps. So from here, you can do a reverse coyote jump to get up to this wall, get up here. And yeah, this reinforces what they just learned in level 25. Next level is 27. Not much to say about this. I just made another symmetrical looking level, and like how going up here you have to do this type of jump. Up here you have to do a different type of jump. It's actually one of the first levels I made specifically for 8 squared and not just for the level maker. Now next level is Leap. So actually I specifically designed this level to be the level right after the reverse coyote jump tutorial, because it forces you to do like a reverse coyote jump here, jump over here, then jump back, then do a coyote jump from there to reach the exit. But after I played this level, I realized that this level is a bit easier compared to this one. So yeah, I moved this one a bit later, since it might be too much to force the player to do those tricks consecutively right after just teaching this. I just want to reinforce this a little bit and like do the actual challenging ones right after in the future. The next one is 29, which is Race. This was one of the first hard levels that I made for the level maker. Way back when the level maker was still fresh, and it's one of the ones that still hadn't implemented coyote jump. So this is precise movement, precise jumping, like speedrun type movements. That's why it's called Race, because you need to go through the entire level at full speed without stopping. Next up is Fault. So this one is based on the jump from level 29 in 8 squared over 2, which you had like this wall to the right and black panels above you, where you have to jump across this tree wide gap, whole jump across back and forth until you get the exact right position here and jump straight through this hole. And I just copied that jump and put it here, so you have to do it twice in a row. But 8 squared is much more difficult than the 8 squared over 2, so like what used to be the third to the last level there is just not even halfway through the 8 squared. The 31 is Dam, so this was inspired by level by someone unknown. So someone's in their original level, I think it had way less black tiles, but I wanted to position this somewhere in the middle. Yeah, added more black tiles to make it more difficult, and also distinguish it from a later level that we'll see. Next level is Isles. So this one I made specifically to become the boss level for reverse coyote jumps. Here I started with trying to figure out how to make the player do two reverse coyote jumps in one level, and I ended up with this jump where you start from here, you need to go up here and do another reverse coyote jump here. Here you just need to do like a maneuver similar to the previous levels in this group and GX it. The next one, level 30, is where it's called Megent. So yeah, I couldn't think of any good thing to teach the player anymore at this point, or the other things I wanted to teach were reserved for the higher level. So here it's kind of a filler level. It's called Megent because it's the first level of the second half of the game. And here you're just forced to save yourself while falling. Actually, that's kind of a mini theme for this group, is saving yourself from falling, because here you need to save yourself from falling here, then you need to do it twice in this middle, then go back up here at the end. So here you have Bounce. This is actually one of the hardest levels when the level maker was still new. And this is made by Dalmon, so this is actually the easiest level made by Dalmon that has reached the 8 squared full level list. And it's called Bounce because from here you need to jump here, and then you can't start from here. You need to start from here, then wall jump here, bounce from this wall, do a coyote jump, bounce from this wall, do an under jump, then you could also do a under bounce in this wall, and then go back to the exit. So this was, at the time, one of the most difficult levels made for the level maker, but oh, how innocent we were back then. Next level is 35, which is Studio. So I made a homage to Video Dojo in an earlier level, and I also wanted to give an homage to Studio. So I first tried to make her face or something, but I couldn't make a decent level or make the pixel art look good at all, or make people realize that it's supposed to be Je. So I just opted for Jeje, which is that's the first two initials of her name. And actually, originally for this level, I put this exit over here, but I felt like this initial jump was way too difficult. Like, it's actually a pretty precise jump. And when I put the exit here, that also makes this jump, getting up here and reaching this exit, also very difficult. And if you miss it, you're gonna hit this and explode and have to do this difficult jump all over. So I just wanted to focus on this difficult jump, make this a little bit easier, so I moved this to the right. Number 36 is Needle. Actually, this jump was the first level that I implemented after changing the hitbox of the person Nodon from a touch sensor to the cylinder, the breakable cylinder system. So with the touch sensor mechanic that was using at the very early stages, this jump is actually impossible because like the touch sensor is very finicky and like it's gonna mistrigger on one of these as you pass through this needle here, this eye of the needle here. That's why it's called Needle. But after implementing the cylinder hitbox, I tested it on this jump. Like I thought of what could be the most precise eye of the needle jump that I could think of, and I was happy to see that it was finally consistent. So that's what cemented to me that I should use the cylinder brake hitbox mechanic. The next level is Combine. So this was the hardest level that I made for the level maker way back when. So this is called Combine because well I was trying to make the hardest level that I could think of, and what I ended up doing was just combining different difficult jumps to force the player to go through in a row. So for example, here we have to do this wall jump here and jump through this small gap. Here we have to do a difficult jump where you have to jump through the small gap from here without overshooting or hitting your head here and falling down and hitting your feet here. And after this, you have to do a continuous coyote jump here, or wall jump here, then coyote jump right after. Then this jump is also really precise, so you need to get high enough here but not too high that you'll hit this. So you get high enough here so that you'll be aligned perfectly to reach this. So from here to here is also a very difficult jump. Like if you go too high, you'll bonk and hit this, and you need to do a medium sized jump here. So it's a combination of many different tricky jumps. So number 38, I designed this level when I had the thought of what if I made a level where the exit is right above the spawn, but instead of it being easy, I force the player to, even though it's right next to each other, I force the player to go around the entire level, to like go a whole 360. I thought it was kind of an amusing idea for a level and an interesting idea for a level, so that's how this level came to be. Next level is Drop. Here I was also testing like what kind of different jumps are possible with the physics that I set up. And actually originally this platform was one block lower, so there's actually just one high gap here. It's actually possible to jump from here and somehow fit yourself into that gap. But I found that it would have been too difficult, like as a lower level here, and it also kind of inconsistent to do. So I ended up just expanding it to 2 and make it much easier to do. But it's still quite difficult, that's still level 39. Now level 40 is Seat. So this is one of Dalamon's original levels. So it's just a normal difficult level. You have to jump here, and yeah, from here you need to jump up, but not too much to the right. And then save yourself, or yeah, don't go to the wall too early or you hit this, or don't go to the wall too late or you'll hit this, and jump between these and get to the exit. Level 41 is Maker. So for this level, I just wanted to make a Z as like my emblem for my name, which is a Z. And at first I wasn't sure if this jump was possible, this two black tile jumps. When I tested it, it was possible, so yeah, I made the whole level just teaching the player that they can do this jump. Actually, yeah. So this level was kind of a boss level. This is like a lot more difficult than these other few levels. And it's kind of similar to the type of jump that you did here. Like you have to fall down and wall jump just in time to save yourself. And it's kind of the same idea here, where it's the same jump but it's much more difficult with these black tiles here. And 41 serves as a sort of tutorial for these two block long jumps where you have a ceiling. So yeah. 42 is Jaws. So this is actually based on a later level. So I originally made a later level and felt like that level was way too difficult. And this is an easier version of the jumps that I implemented there. So yeah, I thought they're different enough that they can be separate levels. So yeah, I split this level off and put this here and just repeated this specific jump multiple times and reinforcing this jump before I force them to go through that difficult level later. And 4-3 is inverse. So this is just kind of a follow-up of this level. I wanted to force the player to do a bit more 2-block jumps here. Now I force it to do it twice in a row, get them more accustomed to it. And 44 is claws because it looks like claw marks. And this is also another visual first level, so I first placed these blocks, thought it would look interesting as a level, and just placed these black tiles. And when I played it, it was decently hard enough that I had to put it up here around the 40s. Level 45 is Rise, so this is based off of level 14's last jump. So if you go back to level 14, yeah, I had to nerf this level quite a bit because it was level 14, but I really like this last jump where you have to go through this slit here while jumping around this area. So I just implemented that jump 3 times. So, or I guess 2 times. So you jump up here, then you need a coyote jump. Yeah, I also added a coyote jump to spice it up more. So coyote jump here, whole jump here, and do the jump I wanted here, then do it again here. Number 46 is Miss. So when I was making this level, or my only goal when I was making this level was I wanted to make a level where I wanted to put the exit at a really close position that you would think you could just reach it, but you can't, and you have to go around the whole level to reach it again. So it's kind of similar to the loop level, but here, like, you can reach it, you can do this and get this, go up here, but you can't really reach it. To reach this, you need to go all the way up here, do a coyote jump here, and reach this wall, and from this wall you can do a wall jump. And if you miss it, and it's designed to be very easy to miss. So if you miss it, you're gonna go back here and do it all over again. But if you hit it just right, you'll hit the exit. 147 is Pass. It's another placement first level. So I just made this grid and just gradually put black tiles until I was forced to do like difficult jumps, and yeah, ended up becoming a pretty cool puzzle type level. Next one is Totem. So here, this was originally like around the 20s because like when I first made it, I cleared it in like 2 tries. That's when I started playtesting the full game for real. I really got stuck in this level, so I had to put this way further because I started to hate how inconsistent some of these jumps are. Next level 9 is Array. So here, I just wanted to implement the specific type of jump. I wanted to implement this type of jump, a short coyote jump. So here you have to do a coyote jump, but go really low and just tap the jump button really lightly so you don't hit this one. So I thought it was an interesting jump to implement and to like make it visually interesting, or also like vary the jumps a little bit. I added these extra one block jumps here, and they look like a bunch of arrays. Next one is Drill. So this was the level I was talking about when I made Jaws here. So this, or level 50 is basically just Jaws, but I put black tiles here and here. Specifically this jump. Yeah, this jump specifically. So you have to walk off at a very specific speed here to somehow land here safely without hitting this or hitting this. I thought this jump was really, really hard. So I didn't even force the player to do it twice here. Like, there's a much easier version of this jump. Here, I just forced the player to do it once here since I thought that was enough for difficulty. Number 51 is Angel. Another visual level. I wanted to like make a minimalist type level. I was really happy how it came out. And it looks like one of those RPG bosses. Like there's a head, there's the hands, floaty things behind it, there's the legs. It's also very interesting how, like with just minimal number of blocks, I could force the player to do these interesting jumps around the entire level. Number 52 is Slide. So this level was inspired by another level by Delmon, but it's not. It's very different from his original level. His original level was way harder, but he mostly focused on this jump where from here you have to drop off the edge and then do a wall jump. So I thought that jump was pretty interesting, but I didn't want to force the player to do it way too much. I didn't like that jump, but I wanted to include it into the game at least once. So yeah, that's what this level came out to be. Level is 53, which is nerfed. So this was a level originally by Diamond, but his original level had a black tile here. And the history behind that was that I was literally never able to finish this level. And like only after like 200 tries, I was able to get past this point and reach this wall. And even then, like, it's still not easy to get from this wall to the end. And after a bit of testing, I found out that like the jump is really precise. So like even if you're frame perfect, running at full speed, going up here, the way you reach it is not guaranteed. You need to basically like have a very specific starting point or have a very specific speed. You have to not be going at full speed, but like a little bit behind full speed. It was really precise to reach this exit, and I thought it was way too difficult to be included into this game, or maybe it's too inconsistent. Like there's no strategy that you can do to make sure that you can always hit it every time. So that was too hard, so I nerfed it by removing this block. And even though it's still a difficult level, but yeah, not like how it was before. That's why it's nerfed. Next level is Rebound. So yeah, I suppose Rebound is right now. Yeah, so Rebound. Here I just wanted to implement a jump where I force the player to jump to the right with some speed to force them to clear this, but also come back or rebound back, and in time be able to hit this wall and do a wall jump. So I thought it was an interesting jump, and it turned out to be pretty difficult, and it got put in this 54s. Next 55 is Zone. So here we finally introduced the ceiling jump that was featured in the 8 squared over 2. So that's the hardest jump in 8 squared over 2, where you have these black tiles, white tiles, and you have to hit your head on the ceiling, fall down here, hit your head on the ceiling, fall down here. And I basically forced the player to really learn how to do this jump by doing making them do it multiple times. And it's called Zone because to reach this end, you need to be in the zone and like be able to do it consistently. Because here you have to do it like 6 times in a row. Or 56 is long. So this one you'll notice most of these levels near the end, I just wanted to implement a very specific jump that I thought was interesting and I wanted the player to learn how to do. And for this jump is a long, low height coyote jump. So here is very tricky because you have an extremely long gap that you need a coyote jump for, but you can't do a full coyote jump because you're gonna hit your head here. So you need to fall off and jump at the very last moment before you hit this, but also jump a very specific amount of time. So it's not high enough that you hit this, but high enough that you'll get here. So it's a very difficult jump. And actually some people thought that 56 is way too low for it, but when I was testing this, I got really consistent at it, so I had to put it a bit lower. But it's debatable if, yeah, it might be better to put it at a higher level in hindsight. So next level is 57. So here, this is kind of a follow-up of this level. So this level it's a little bit easier because you can have speed here, and like this jump is much easier when you have speed going into it. But here, like this first part is not to scoff at either. We're getting up to the high 50s, so I become less forgiving in the level design at this point. But yeah, here I forced the player to do the ceiling jump, but now from standing here. So he just like standing here, do ceiling jump here, and reach the ending. The next level is 58, which is precise. So this used to be way earlier, because to be honest, this is a pretty simple jump. But this type of jump I really dislike. I really dislike this type of jump where you need to have a very specific low height and low speed. I'm not really good at controlling the mid speed of the joystick. So for me, at least, this was a very difficult level, but for other people, this would actually be much easier. And here I had to force the player to do it like 5 times. Next level, 59, is Spiral. So this was inspired by a level by Disco. So Disco had a level where it goes on a spiral. But here, I just wanted to add more levels that had the ceiling jump. So like I pushed this level down by 1 and I added these blocks to force the player to do that ceiling jump twice again and make them go down here. The next level is Slow, level 60. So when I initially made this level, I thought that to clear this level you needed to do this very unique coyote jump, where you do a coyote jump and then immediately look the other way before or as you're doing the coyote jump without changing direction. So we just show you this here. Okay, something went wrong. Never mind. Actually, I know what went wrong now. So actually, fun fact, or interjecting here. Fun fact, for the map array, right? I'm adding all of these maps and like adding these numbers with a lot of decimal points together. But the order that you add numbers together actually matters, because like when you go to the very small decimal points, the precision of the numbers gets really wonky, and the order that you add them together changes what would be the output if you do it many times enough. So here I'm adding stuff 320 times. So sometimes the order would matter, and yeah. So what happened here was in the 8 squared crack version that I made, I deleted the map array and repasted it, and when I did that, the orders of all the connections got reset. And after that happened, yeah, some of the bits got flipped, and that's what caused like these random black dots to spawn here. So anyways, for this level, yeah, I thought there was a very specific jump you need to do to clear this jump, but I think it turns out that you can actually just do a precise coyote jump here. It's actually way easier than expected, so yeah. This level turned out to be kind of a breather level instead of being a difficult level that's kind of worthy to be level 60. And also it's called slow because like you do the slow wall jump or the slow coyote jump, and these look like snails. Next level is Towers. The Towers was originally made by Valmont. This is just a very difficult level that he made like very late, as I think he made it while I was making the level 8 squared, and yeah, I thought it was really neat and really difficult. It gets more difficult as you go on. Not much to say about this one. Next up is 62 Gauntlet. So this is actually in contention to be one of the hardest levels. This was originally made by Dalmont again, and actually never beat it before I started developing 8 squared. When I started developing 8 squared, I had more skills with the person Nodon, and I was able to clear it for the first time. I thought, yeah, as a really difficult level, worthy of being almost or one of the final levels of 8 squared. It's called the gauntlet because you have to do so many difficult jumps here. You need to do this difficult start jump, small jump from here, and do this like fall off, which is very difficult, and jump from here is also difficult. Then get here, which is also difficult, and jump here. This part is a bit easier, but yeah, getting through here is a gauntlet of difficult jumps. You have to string them in just one perfect run. Now this one, 63, is trick. So this level, I didn't want it to, the final levels to just be like consecutive, very difficult, hard to do jumps. I wanted some levels to be more technical, so this was my attempt at making a technical level. So here, when I was making this level, I figured out that it was possible to do a very difficult coyote jump, where you do a coyote jump here, and you move, and your momentum, you can flip your momentum to the left, but only just a little. If you do a normal reverse coyote jump, when you go to the left, you immediately spike towards the left. But here, there was a very, very precise way where you can do that, but very slowly. You need a very specific set of inputs. And actually, when I tried to do this in my first clear, it took me like hundreds of tries because it's such a precise trick. And because it's such a precise trick, I didn't want to add more stuff to it, or like force more jumps to do after you do the precise trick. I just wanted to do it once, just once in their life, do that difficult trick, and then give them the free win. But I think it turns out it's actually possible to skip that. You can do a very, very precise normal coyote jump to just barely reach this thing. I think that's an alternative solution to finish this level. Last level is the finale. So I think this level is kind of equal in difficulty as 62. It's just a string of many difficult levels, and I made it specifically to be the final level of this game. And as the final level of this game, I also tried to make an homage to the final level of 8 squared over 2. If you remember, in 8 squared over 2, I wanted the player to do that ceiling jump followed by a coyote jump. But in that specific game, you can cheese it by just, there are multiple ways to cheese it, but here I made sure that I'm able to force the player to do the ceiling jump followed by a coyote jump right after here, by adding a few more blocks and placing these very specifically. So yeah, this whole level is based on implementing that specific jump. And after I put that jump here, I just added a few more, a lot, just made it as difficult as possible while still being possible. Here you have to do this difficult jump here, and then medium jump, this kind of medium, getting to here, and you need to do a sailing jump here, do a medium wall jump here, hit here, then go down here, then do the difficult sailing jump followed by a very, very precise coyote jump in this area because you don't have much space here. Then right after doing the coyote jump, you need to hit this perfectly, jump off here, and then you need to do this whole thing consecutively, because here you have to do this 2 block jump, and these 2 block jumps require you to have some speed. So if you just stop here, you're basically screwed. You can't finish this. So I need to do this whole maneuver in this top part in one straight go. And if you do that, you've cleared 8 squared. And that's all the levels in 8 squared. Hope you found that interesting. That's it for me in this video.